with what we are learning today, which is conditional probability. Now, before we get started, a couple of things. Your We're gonna call it a quest. It's not really a quiz, but it's not really a test either. It's kind of something in between. Will be Thursday on this unit. All right. I will give you a review tomorrow. All right. So today's really going to be the last lesson. Even though we do have like a couple more in there, but we as the Math 2 people decided to stop it after this lesson. All right. So this warm up goes off of the data we gathered yesterday, as well as gives you an idea of our next topic today, which is all about conditional probability. All right. So I went ahead and filled in the same frequency table that we came up with at the beginning of class. So for number 2, given that a person is selected is yes to the evil eyebrow, what is the probability that they are also yes to the taco tongue? All right. So if we know that they are yes to the evil eyebrow, all right, meaning they fall somewhere in this column, it wants to know what is also the probability that they will also have the taco tongue. So what do you guys think? So first off, what would it be taken out of? What would your fraction be taken out of? 7. Why? Because we know for a fact that they have the evil eyebrows. So they have to be one of these 7 people. All right. So how many did we have that had the taco tongue? 5. So this will be 5 out of 7 chance. So a little bit different than how we used it yesterday. We're not actually taking it out of 23. We're taking it out of the number of people that had the evil eyebrow. All right. So as a decimal, what would that be approximately? It'd be what? 0.714. So that's approximately 71.4%. So this is what conditional probability is, guys. They typically give us a condition. All right. And then they ask, well, what's the probability of this happening given we have this condition already? All right. That's what conditional probability is. There's literally an already given condition that we know for a fact happened. And then they want to know what's the probability of something else happening at the same time. All right. So, given the person selected is no evil eyebrow, what is the probability that they are yes to the taco tongue? So that means we're looking at this column right here. So given that they're no to the evil eyebrow, what's the probability that they're yes taco tongue? What do you guys think? 12 out of 16. So if I simplify that fraction, it's what? It's 3/4, which we know to be 0.75, which we know to be 75%. Now, using conditional probability, we can then determine whether these two events are what we call independent of each other. So they gave us the definition of independence. It says if two events are independent, it's if knowing whether or not one event has occurred does not change the probability that the other event will occur. So in other words, these two probabilities should be pretty darn close, if not exactly the same. All right. They actually should be exactly the same if they're independent. Because knowing whether they have the evil eyebrow or not should not change the probability of them having the taco tongue. So could we say that these two events are independent? So given how close they are, I would say yes. All right. But if this was like, let's say this was like 20% versus 80%, all right, then it would be a no because one does affect the other. So we would say yes, they are independent. Because the probability of them having taco tongue I can spell correctly is about the same for evil eyebrow and no evil eyebrow. So that's what it means to be independent. In other words, literally, the probabilities will not change. And you have to test, the probability of something happening knowing that something else will happen, and the probability that something will happen knowing that the other thing will not happen. You got to check both. And if the probabilities are about the same, they're independent. All right. So, number 5. So, they gave us a whole new set of data. All right. Still dealing with the evil brow and the taco tongue. But instead of our class data, they just said some other class. All right. So, what is the probability that yes, they will have a taco tongue? So, just the straight up probability that they will have a taco tongue 24 out of 30. All right. So, simplified, that's what? Well, the fraction simplified. 4/5. So, the decimal should be 0.8, which is 80%. What's the probability? Okay, so here's some vocabulary right here. When you see this symbol right here, this symbol means given. So the way we read it is, what's the probability of yes, taco tongue, given yes, evil eyebrow? All right, that's what that little line means, given. So that's how we typically write conditional probabilities. So if we know for a fact that they have evil eyebrow, what's the probability that they also have taco tongue? It should be 8 out of what? Not 30. 10. You got to look at this column because we know for a fact that they have evil eyebrows, so it has to come out of that column. So 8 out of 10. So that's 4/5. So that's 0.8 or 80%.
So you have the second one, the one that you're pulling it out of,
Say one more time.
the second.
Right. So yes. So if we're given that they for a fact have evil eyebrow, we have to take it out of the evil eyebrow column. So we have to use the total of the number of people that have an evil eyebrow. Because we know for a fact that this because we know for a fact that whatever student they pull to test this probability is going to have that evil eyebrow. All right, what's the probability that yes, they'll have taco tongue given no evil eyebrow? It should be 16 out of 20 because we're pulling from this column. So 16 out of 20. So what's that as a simplified fraction? 8 over 10 or 4/5. So 0.8, so 80%. So are yes taco tongue and yes evil eyebrow independent? So thumbs up if you think yes, thumbs down if you think no. 1, 2, 3, go. So remember, independence means that regardless, the probabilities of one happening over the other will not change. They won't affect each other. So yes, they are in fact independent. Why? Anyone? Right. If we look at the two probabilities of the taco tongue happening with the evil eyebrow and without the evil eyebrow, they are exactly the same. So yes, they are independent for that reason. So, a couple of quick notes here. All right. So first off, conditional probability, which we read as P of A given B, is the probability of A given B occurred. So in a two-way table, which is what we were doing, we only focus on the rows or columns of the given condition. Now, the actual formula for conditional probability, so P of A given B, that's equal to the probability of both happening over the probability of the given happening. So another way you can write it is P of A and B over P of B. You can also write it as P of A intersection B, because remember the upside down use an intersection. We talked about that yesterday. All over the probability of B. So this is actually the traditional formula for how you would find conditional probability. You take the probability of both happening and divide it by the probability of your given happening. Shh. And then lastly, independence events are knowing whether or not one event occurs does not change the probability of the other event. So in other words, the probability of A, all right, it should be the probability of A given B. It should also equal the probability of A not given B or given not B. So the complement of B. So real quick, I want to go back and check, all right, and check to see if this formula works with what we got from the two-way table. All right. So let's first check the probability of yes taco tongue given yes evil brow. So I need the probability of both happening. So based off of our data over here, what's the probability of both happening? It's what? 5 out of 23. So we need the probability of both happening. So that's equal to 5 out of 23, because 5 people yesterday out of 23 could do the taco tongue and the evil brow. All right. Now, what was the probability of just the evil eyebrow happening? No, just the evil eyebrow. So they could do the evil eyebrow. Whether they could or could not do the taco tongue. 7 out of 23. So 7 people yesterday could do the evil brow. So what we would do is we would divide these two fractions. So we would do 5 over 23 divided by 7 over 23. Now it's a complex fraction, but it looks ugly. But we can also rewrite it like this. 5 over 23 divided by 7 over 23. Which don't put in your calculator, we can do this by hand. All right. How do we divide fractions? Keep, change, flip. So keep the first, change the division to multiplication, flip the second. Now, before I can even multiply across, there's one thing that you guys notice. The 23 in the top and the bottom, so those will just cancel out. So I'm left with what? 5 over 7. Is that not the probability that we got from our two-way table? Yes. All right, so it does work. All right, so even if we didn't have the two-way table where we could look at the column and take the probability from that column, if I just gave you this data and not the two-way table, you could still get that probability through the formula. All right, any questions on that? So those last couple of questions on that warm-up, I do want to go through them before we get into the official notes today. All right. So take a minute and look at number 1. All right. So it says that students at the University of New Hampshire received 10,000 course grades in a recent semester. The following two-way table breaks down these grades by which school of the university taught the course. The schools are liberal arts, engineering, physical sciences, and health and human services. All right. So, and they did not total these for you, so just take that into account. They're not totaled. So you probably need to total each of the columns and everything. But choose a University of New Hampshire course grade at random. Consider the two events, E and the grades from the EPS course, and L. So the grade lower than a B. So E is the grade from an EPS course, so that's engineering and physical sciences, and L is a grade lower than a B. So I want you guys to take a minute and answer number 1. So I want you to find the probability of L happening given E, where L is a grade lower than a B, given E, which is your engineering and physical sciences course. So remember, the table are not total. Make sure you total those tables. Just do number 1. So we know for a fact that they took an engineering and physical science course. So what's the probability that they got a grade lower than a B? So anything from an F to a C. So again, first thing I would start with, I would start by totaling each row and column of your table. That'll make your life 20 million times easier. All right. Oh. All right, so what I want you guys to do, turn to your neighbor and compare answers. So turn to your neighbor, take a minute, and compare answers.
I got 50. 800 over 1600.
Because L is the amount of people who got under A, B, and E is that you're taking that. So it's L given E.
All right, and let's come back together. All right, so let's go with Sutton. All right, tell me how to set this up. Mm-hmm.
I got 800 because it's lower than B. And then I added all of the engineering and physical science together. And I got 1600. So it's 1/2.
Good. So 800 over 1600, because again, since we're given the engineering and physical science class, we're looking within this column. So if you simplify that, you should get 1/2 or 50% chance of them getting lower than a B. Now, it then asks, are events L and E independent of each other? All right, so what it's asking is that, remember, that means that they're independent of each other. We already know that L, given that there is an EPS class, is true. All right, but we also need to find the probability of L happening given it's not from the engineering and physical science classes. All right. So take a minute and find that probability, because we can't determine independence without it. Complement. So remember, complement means it's the opposite of E happening, or E doesn't happen. So basically, it's pretty much, yep. So you combine the other two and go that way. So total, how many people are in each, or total? So if you know they're going to get lower than a B, or what's the probability they get lower than a B, given that they're not taking an engineering physical science class? We're looking at the other people. Just put it in and then hit enter and then math and enter. So you actually want to add up these two and add these two.
What are you guys doing in here?
All right, guys, I'll give you another minute. All right, guys. Shh. Hearing a lot of outside chatter, so I'm assuming y'all are done. So go ahead, turn your neighbor, compare answers.
We need to like start doing.
So like for my thank you cards, they're like pink, blank little cards. So like one's in the white and one's in the other. There's like one black one and a white one, and then there's the I know they are. What are you adding them for? It's great.
What did you get? What did you do? I could have gotten you so many shells. We all have. But today we're gonna have so much fun at the work.
All right, come back together. So walking around, just hearing some of y'all's answers are all over the place. All right, so let's talk about it. So first off, E complement. What two classes are in the set of E complement? So we're talking about the liberal arts classes and the human health services classes. That is engineering complement. All right, it's basically those two classes. So that means we are looking at this column and this column at the same time. All right. So what was the total that you got for this column? Like 6,300? What about for this column? 2,100. Now, that means that since we're looking at these two columns at the same time, we need to add those two totals as our denominator. So this will be 6,300 plus 2,100. Then we want it to be lower than a B. So which two numbers am I looking at for these two columns for lower than a B? 2268 and 588. Good. So we would have to add those two together. All right, so if I do 2268 plus 588, what do I get? It's what? 2856 over 8400. So if I simplify that fraction down, what would it be? It'd be what? 70 over 17 over 15. All right, what's that about as a percent? It's about 34%. Or it actually is 34%. Yeah. So, based off of that, are these two events independent of each other? No. So, the probability of it happening given E is not the same as the probability of it happening not given E or given not E. All right. So, that means that it does affect the other. So, this is not independent. All right. So we're going to do this last one together just for time's sake. So, given that the course grade is not lower than a B, so we're given the fact that it's not lower than a B, what is the probability that it came from the EPS course? So in other words, we're finding the probability of E given not L. So remember, the dash is another way to see complement. So you can either see it with a little C, you can also see it with a little prime dash. All right. So first off, similar to the last one, we're looking at they're not given a lower than a B. So which two columns am I explicitly looking at? The A and B columns. So what are my totals for both of these? So what's the top one? Just for marking sake. It's 33 what? 19? 92. What's the bottom one? 29 what? Okay. So that means when we take our probabilities, we're going to be adding those together. So 3392 plus 2952. Now, what are we looking at specifically? What two numbers within these two rows? You could, but I'm just writing it all the way out so you guys can see where I'm getting it from. The ones in engineering. So we're looking at these two numbers right here. So we need to add those together too. So if I add the numbers together, what would it be? 800 over 6,343, you said? 344. All right, so if you simplify that fraction down, what would you get? 100 over 793, which, what is that as a percentage? It's approximately 13%. You should have gotten like 0.1261, so that's about 13%. All right, so this was kind of a prelude into conditional probability just to get you thinking about it. So go ahead and put that away for right now and take out your packets and go to page 15. All right, so guys, you should have your packet out. Page 15 should be open. All right. So, like we already talked about, conditional probability, it literally is what it sounds like. We're given a definite condition, and they want to know the probability of one event happening given another event. Given that we know another event either happens or doesn't happen. All right. Now, again, it can be a little bit confusing with conditional probability because you have to really pay attention to the wording. Because if you pick the wrong order of events, it can mess up your answer. All right, so you got to be really careful about the wording. So the probability of one event occurring changes depending on other events occurring, and we say that they are a conditional probability. All right. And again, the easiest way to figure out the conditional probability without having to use the formula is through two-way frequency tables or charts. All right. So this is a similar table to one that we did yesterday. All right. So it says that in this study, 52 graduating seniors were surveyed as to their post-graduation plans and were sorted by gender. So M is male, F is female, C is going to college, N is not going to college. So they want us to find the given probabilities. So what is the probability of whatever student that we pick being a female? So take a minute, write down your answer, don't say anything. So the probability that the student will be female. So take a minute, write down your answer. So there's no conditional yet, it's just a simple probability. All right. Let's go Reagan. What's the probability of them being female? 22 out of 52. So if I simplify that fraction, what would it be? It would be 11 out of 26. All right, did anyone happen to take it as a percentage? It's about 42%. All right, take a minute, find the probability of them going to college. So don't say anything, just write it down. Shh. This is independent work. I shouldn't hear any talking. All right, Claire, what's the probability of a student going to college? 29 out of 52. So that shouldn't simplify because 29 is prime. So it's about 56%. Now, they then want us to figure out the probability of them going to college given that they are female. So we know for a fact that this student is a female, and we want to know what the probability is that that female will go to college. So before we actually determine this, let's actually kind of look at the female going to college, all right? So we're essentially taking a smaller set of our big frequency table and making a small Venn diagram. So looking at our frequency table, all right? How many students are female and going to college? So they're female and they're going to college. How many? 13. How many are just going to college? 29 total. So if we take out the ones that are female, how many are left over? 16. So in other words, it's whatever the males are. So how many are female total? So there's 22 females total. So if we take out the ones that are going to college, there's 9 left over. Now, how many students did I not use? 14. If you add these up, we have 14 left. Which, if you think about it, we use these 3 numbers, so the only thing that's left is the male's not going to college. So, given that I know that they are female, so we know for a fact that they are in this circle. All right, they are landing in that circle. What would be that probability? 13 out of 22. Good. So how'd you get that? Mm-hmm.
And I narrowed it down to go into college and female. And I contributed to the
Right. So 2 ways you could have done it. If we knew that they had to fall in the female circle, you could have added this up total. So there's 22, and there were 13 that were doing both. Or you could have looked at the 2-way frequency table. You use the total number of females because we know that they're female, and you use the number of them going to college. All right. So typically, guys, when you're dealing with the way that they write out a conditional probability, this is the probability that we're trying to find. And this is the probability that we're given. All right, so be careful with how they write it because there is a difference. So now they want to know which is more likely that a person picked at random will be going to college given they are male. So they're going to college and we know for a fact they're male. So this will be the probability of C given M. Or that the person will be male given that they are going to college. So we know for a fact that they're going to college. So what's the probability that they're male? So first off, let's do the probability of C given M. So that means I'm looking into what column? The male column. So since we're given that they're male, we're looking in the male column. So that means my entire probability will be taken out of what? 30. And how many of those males are going to college? 16 out of 30. All right. Now, do me a favor and convert that to a percent. So as a percent, what is that? All right, so it's about 53%. Now we're going to do the inverse of that. So we want the probability that they're male given that they're going to college. So now instead of looking at the male column, we're looking at the going to college column. So everything that we take is going to be out of what number? Someone who hasn't talked yet. 29. And how many males is that? 16. So as a percentage, what is that about? 55%. So which one is more likely? So they're going to college and they're going to be male. All right. So the probability that's most likely to happen is that they're being male given that they're going to college. So guys, with conditional probability, order does matter. All right. We're using the same two events, but we switched up the order of them. So it does change your answer. All right. So be very, very careful about that order. All right. Let's look at the next page. So we can generalize the process of calculating conditional probabilities based on the counts and way to calculate the conditional probabilities and other probabilities. So in a generic Venn diagram on the shown, each dot represents an equally likely outcome of the sample space. Some fall only into event A, some in only event B, and some in both events, and some in neither. All right. So just for our sanity's sake, let's just go through and actually put numbers in the sample space. So how many happened in only A? 6. So there's 6 dots, so 6 happened. How many happened in only B? 5. Both? And neither? 3. So how many total in my sample space? 17. You just add up all the numbers. All right. So consider the probability of A occurring given that B has already occurred. So they want us to give a formula for this probability based on the number of elements in each set and their intersection. All right. So they want us to know that what's the probability of set A given that B has already occurred. Now, we already talked about that formula. So on your warm-up, what did I say the formula for conditional probability was? So on that back of your warm-up in the quit notes, I told you what the formula for conditional probability was. What was it? P over A given B is equal to what?
Wait, P parentheses B.
So basically you take the intersection of A and B, so you're finding both, and the probability of just B happening. So we're going to find it first just by using the Venn diagram. All right. So we knew that B has already occurred. So we're explicitly looking in the B circle. So that means our probability is going to be taken out of what number? 8. So what's the probability of A occurring in the B circle? 3. So in the B circle, the only place where there is A is where the overlap is. So you have a 3 out of 8 probability. All right. So now let's use the actual formula and see what we get. So what's the probability of both A and B happening? So just the total probability of A and B happening. So B. Nope. So guys, the intersection. What's the problem? You're overthinking it. This is just a simple one. What's the probability of both A and B happening in this sample? 3 out of 17. What's the probability of just B happening? Or my bad, what's the probability of B happening? 8 out of 17. So if we do 3 out of 17 divided by 8 out of 17. So remember, if we're dividing fractions, we can do what? Keep, change, flips. This is the same thing as 3 over 17 times 17 over 8. What happens? The 17s cancel, so we're left with 3 over 8, which is exactly what we got up top. So guys, it works either way, all right? But the part A only works if you're given some form of representation, whether that's a Venn diagram or a two-way table. If they don't give you that representation, you have to use the formula. So this formula is very, very important. So this is how you find any conditional probability. So last thing we're going to do. So these kind of a mix, all right? So a survey was taken to examine the relationship between hair and eye color. The chart below shows the proportion of people surveyed who fell into each category. If a person was picked at random, find each of the following conditional probabilities and show the calculation we used. So just for practice sake, I know you can do it based off of the frequency table, but just for practice sake, I want to use the formula. All right. So they want the probability that that person will have brown eyes given that they have blonde hair. So first off, what's the probability that they will have blonde hair and brown eyes? So what's the both? So the probability of brown and blonde is what? Is equal to 0.1 or 0.10. So it's the intersection, and it's taken out of the total. All right, what's the probability that they just have blonde hair? 0.35, so we're looking at the total. So I'm going to do the both over the probability of blonde hair happening. So if you put that in your calculator, what do you get approximately or exactly? So do 0.10 divided by 0.35. It's what? 0.285. So 0.285. Is that rounded or is that exact? It's exact. It's rounded? Okay. So I thought. Now, let's say we use the frequency table. All right. So just to double check ourselves, we're going to use the frequency table. So given that they have blonde hair, that means I'm using the blonde column. So I would still do 10 out of 0.35. All right, so it works either way. All right, take a minute, try letter B on your own. So try letter B on your own. Divide the probability of both happening and divide it by the probability of green eyes happening. All right, thumbs up if you're ready. I'll give you one more minute. All right, so let's go with Shelby. What's the probability of both red hair and green eyes happening? 60%. So the probability of both red and green eyes happening? 0.15. Good. All right. Shh. Right. So the probability of just green eyes happening is 0.25. So what did you get as your answer? 0.6. So the last question asks, does having red hair have some dependence on having green eyes? Well, for example, I have red hair and green eyes. It's a lot more common than you think. All right. So do you think that having red hair seems to have some dependence on having green eyes? So if you have green eyes, you're going to have red hair. So let's check if they're independent of each other, because if they're not independent, the opposite of independent is dependent. All right. So we already found that what's the probability of red hair given green eyes? So to find independence, what's the other one we have to check? Say it again. For not having green eyes. So in other words, we need to find the probability of having red hair given they don't have green eyes. So it's the green eyes complement. Or given that they're not green eyes, however you want to put it. So what's the probability of them having red hair and non-green eyes? So both red hair and non-green eyes, what's that probability? 0.05%. If you add these two up, it's just 0.5. Or 0.05, my bad. What's the probability of not having green eyes? 0.75%. You just add these two up. So, if you divide that fraction, what would you get? We based it off of the blue and brown eyes. So these two circles right here. So it'd be about 70% rounded. 0.7? Exactly or rounded? 0.07?
7%.
Good. So, based off of those two probabilities, it's pretty obvious that they're not independent of each other. So, is there definitely some dependence there? Yeah, there's definitely some dependence.
Would it be independent if it was a high number?
No, it would be independent if they were exactly the same or really, really close. So, like, especially since we're rounding, like if it was like 0.59, we could confer that they were pretty close to independent. But since they're not even close, they're definitely dependent. All right, any questions on conditional probability? All right, so your homework for tonight is pages 17 and 18. And while you guys are working on that, I'm going to come around and check off your homework from the past couple days because it's been a hot minute since I checked it. My bad. So let's see, it was pages 3, 4, 6, 9, 10, and 13, 14. So I'll come around and check those. Basically, just have your packet out. I'll look through it.
What'd you say? What'd you
So guys, don't forget I am posting the keys for this homework, so if you ever need to check, they are there. They make keys. Post it like the day after it's due. Well, tell you one here. So it just shows me by mark.
I need a table. I can only do tables.
Because these are my only 2 days where I actually have
Boys, make sure you're working. That's my change. I'm trying to get a little so your bus change good. I would watch it. My job. I was my mom's actually, I do too. I forget. My charities. Yes, it's there's a lot of stuff with the titties. Every like your unit. Somewhere's not. There's so many. By the end of the day, I'm just like, and I always
What is 31 from the sport?
It's not for the, what we learned yesterday was the formulas, both of the ones that you have, there's like something over something minus what both of them are. No, it'd just be probability of one plus the probability of the other minus the answer. And that would be the or.
We should have a table. Little flex. Yeah.
Like, you have like one I just like, oh, yeah, where you just like.
But for my thing,
Alright guys, we only got about 4 minutes left in class. Go ahead and pack up. Make sure your calculators are put away clean around your desk. Boys, we're not doing the tricks today. Come on, put my stuff away.